Hello everyone, greetings of the day. I am Arun Kumar, a PhD scholar at IIT Jodhpur, working under the supervision of Dr. Nishant Kumar. Today I will be presenting my PhD thesis work on digital twin design and development for two-stage single-phase grid-connected solar photovoltaic system. In the slide, left hand side, you can see the layout of two-stage single-phase grid-connected solar photovoltaic system, which is commonly used in distribution level applications such as household, city parks, and small commercial setups. From the system, the sensor data goes to data collection and pre-processing unit. Here, the clean data goes to digital twin platform. For my case, I have developed digital twin using three different methodologies: digital twin in discrete time domain, then frequency domain, and data driven digital twin. A digital twin is the virtual replica of physical system that enables real-time monitoring, simulation, as well as predictive analysis. Finally, the predicted output of digital twin is compared with the physical system outputs, and the accuracy of the system is noted. This slide shows the hardware setup used to test the developed digital twin platform and the experimental results. The image illustrates the complete experimental arrangement, which is divided into four parts. Part 1 is the power generation, which is used through the PV emulator. Part 2 consists main control unit. Part 3 consists sensor and the microcontroller unit. And Part 4 consists Opal RT, which is used to develop the digital twin platform. The framework has been tested under 5 different cases. Case 1 to 3 demonstrate the comparison between physical system and digital twin waveforms, showing an excellent matching accuracy around 98%. Case 4 presents the digital twin performance under component degradation scenario, while case 5 illustrates how system parameters vary as the component degrade over time. To conclude, a digital twin has been successfully developed for a two-stage single-phase grid-connected solar photovoltaic system, and the performance of the developed framework was evaluated based on three key objectives: achieving a percentage similarity more than 98%. The proposed digital twin framework provides foundation for real-time monitoring, stability analysis, predictive maintenance, and intelligent decision-making capability. It can be effective and applied to various distribution level applications such as household, city parks, and distribution stations. In future, this work can be further extended in multiple directions: integration of the advanced data analysis, AI control methods, and large scale grid applications. Finally, thank you everyone for your kind attention.